In this video, I'd like to talk about writing the negation of a logical statement. Now, in a lot of these statements, it's counterintuitive what the mathematical negation would be, because sort of conversationally, things might mean one thing, and mathematically, the same words mean something else. For example, if I walked up to you and you were eating, I don't know, a bag of chips, and I said to you, could I have some of those chips? And you said yes. So I ask the question, can I have some of your chips? You say yes and hand me the bag, and I eat them all. Now, how do you feel about that? Do you feel like you gave me permission to eat all of your chips by saying you can have some? Well, conversationally, the answer is no, some doesn't mean all. But the problem is, mathematically, some can mean all. Some actually means anything other than nothing, which includes part of the thing or the whole thing. So if we look at like the mathematical definition of the word sum, not S-U-M, that would be addition, but sum, S-O-M-E, sum means anything other than nothing. Another complication with writing negations of statements is that since we're not doing this symbolically, if we were using symbolic logic P's and Q's and disjunction symbols and injunction and disjunction, conjunction, negation, conditional, and so on, there's only one way to write a negation directly. But in English, sometimes, actually often, there's more than one way to word it. So we just have to be careful. And I'll try to give multiple solutions for each one of these problems. Okay, so intuitively, if I said, what's the negation, or you could think of the negation as being the opposite. What's the negation of all snakes have legs? You might think immediately, no snakes have legs. Well, let's look at a case where you have, let's say 4 snakes. You have snake number 1, snake number 2, snake number 3, and snake number 4. Well, how many snakes could have legs? Well, actually, none of them could have legs also. So out of 4 snakes, let's say there's only 4 snakes in the world, right? The number of snakes that could potentially have legs is none of them. Say none of them. 1 of them, 2 of them, 3 of them, or all 4 of them. All right, so if our statement, we'll call this P. This is actually a conditional statement in disguise. We could rewrite this as if it is a snake, then it has legs. But we'll just call this P. So our statement P is right here. All snakes have legs. All right, I already have all there. Let's say this is statement P. Well then, the negation of P, and I'll use green for the answer, the negation of P has to account for all these different cases. You can't have, if you just said the negation was no snakes have legs, well that's only this case, and it leaves out the 1, the 2, and the 3. So that doesn't work. Every case, and so we could break this down more generally. It doesn't have to be 4, it could be 40, 400, 4 million. But let's break this down as in 3 cases. There is none of them. There's all of them. And then between this, there's some, but not all. So in the example up here of the 4 snakes, the none would be the 0, the all would be the 4, and the some but not all would be the 1 or the 2 or the 3. So between a statement and a negation, you have to account for all three of these. And since there's only a statement and its negation, one of these two is going to have to match up with two of these cases. There's the none, the some but not all, or the part of the whole, and the all. All right, so now that we know our negation, our not P, is going to account for the none. So in this case, in this particular case, there's our negation, there's our statement. So now we have to say something that means that's something that's equivalent to anything but all. So let me erase this so we have some more room. So for number one, the negation of all snakes have legs. Well, I think the simplest way to write this is not all snakes have legs. That's one way to write it, and that would be perfectly correct. And also, we could say at least one snake doesn't have legs. Doesn't have legs. And both of those are equivalent, both mathematically and conversationally. All right, so number two, no firemen wear flip-flops to work. Okay, so out of these three cases, the no firemen, that's the none case, so that's our statement. And so the negation of our statement has to account for the some but not all, or the part of the whole, and the whole. Okay. So how do we say this part in green? Well, let's see. We could say, remember, some means anything but none. So in this case, we could use the word some, or we could use at least one. Those two are interchangeable. The word some and the word at least one mathematically mean exactly the same thing. So we could say some firemen wear flip-flops to work. Or instead of the word some, we could have said at least one fireman wears flip-flops to work. All right, and I think this down here, this is a good way to sort of visualize the idea of the negation of a statement. All right, so number three, some apples are green. Well, we basically just switched the P and the not P, or we switched the negation and its statement. So some apples are green. Some means anything other than nothing. So this is our statement P, which means our negation has to be just the case of zero or none. All right, so that's pretty straightforward. The negation of some apples are green would be no apples are green. All right, and the last one, number 4, at least one child in the class isn't sick. So at least one isn't sick. So that means, let's say if there's 4 children in the class, at least one is not sick. So you can't have all 4 being sick. So you could have at least, well, you could have none of them. You could have 0, 1, 2, or 3 children being sick. But if at least one isn't sick, then you can't have all 4 being sick. So then the negation of that statement would be all. So at least one child in the class isn't sick. The negation would be all children. All children are sick. Okay, so that about does it for negations. Sometimes this is a confusing topic because when we're writing it in English, there's a number of different equivalent ways to say something. And like I said, especially at least with the word some, sometimes the conversational meaning of a word is different than the mathematical meaning of a word. All right, that does it for this video. I hope it was helpful.